So let's try an example which is going to use Bernoulli's and it's going to use the continuity equation. Let's say I'm going to do a practical joke or whatever. I have myself a super saturated water pistol. Woohoo! And I've got a water reservoir down here. I've got a nozzle. So I've got a tube that goes up through here. The nozzle is going to have a diameter of 4 millimeters. Super saturator after all. Okay, so the difference between here and here, where it picks up, is going to be 150 mil. And because this is a pressurized system, remember you pump this thing up, the pressure in here is going to equal 100 kilopascals. We're going to say that it's pumped up to 1 bar. So the guy's been pumping away, it's got a lot of pressure, or she's got a lot of pressure and is squirting the supersaturator. So the question is, how fast does the water leave the water pistol and what is the flow rate? So hopefully this shouldn't be too hard. So what we're going to use here is we're going to use Bernoulli's. So basically heat at A plus the pressure heat at A plus the velocity head at A equals the head at B plus the pressure head at B plus the velocity head at B. So that's the basic components. So remember this, so this is HA plus the pressure at A over rho G plus the velocity squared at A over 2G equals the head at B plus the pressure at B over rho G plus the velocity squared at B 2G. So again, we write down what we know. The head at A. Well, the one we're going to do, we have to measure from the water level because that's the bit that's actually going to be moving. So here, I'm going to call that 0. And that means I can call this 0.15 meters. That way I've got positive numbers. Okay, head at A equals 0, head at B equals 0.15 meters. The pressure at A is equal to, we're using gauge pressure, so we're measuring how much more pressure than there is in the atmosphere. It's 100 kilopascals. The pressure at B, because this squirts out into the atmosphere, the gauge pressure of the atmosphere is 0 kilopascals. So again, we're just trying to simplify it and get rid of everything we can. The velocity at A, because this tank is much, much bigger than this, the nozzle, we can say that the velocity is equal to 0. And this will be accurate to well within 1%. So if this is 10 times the diameter of the nozzle, because it's the area, that's going to be 100 times the area of that. So the difference is going to be 1%. We can live with that. Okay, so, and we want to find out VB. So I look at anything I can get rid of. I can get rid of this term because the pressure is equal on that side is gauge, atmospheric, so that's 0. I can get rid of this term because the velocity is equal to 0, 0 squared, 0. So now I have HA plus PA G equals the head of B. Sorry? I can also get rid of that term, can't I? Because that is equal to 0 as well. So PA, so the only thing in the system driving the liquid is this pressure is equal to the head of B plus the velocity at B squared. So I want to find the velocity. What I might do is I might just cheat now. It's not actually cheating. Let's do this. PA over rho G minus HB is B squared B to G. Add up. 2G is equal. So let's just put some numbers in. Pressure A is 100,000 it's 100 kilopascals over density of water, which is 1,000. It better be water that's squirting at people. Kilograms per cubic meter times gravity squared minus 0.15 meters equals B squared B over 2 times 9.81. Okay, so we can then stick that into our calculator. Simplify that down a bit. 100,000 divided by 1,000, like that, divided by 9.81 equals 10.19 minus 0.15 equals 10.04. 10.04, and remember the unit's going to be meters, equals B squared over B divided by 19.82. .62 squared. So we then go 10.04 meters times that, remember, multiply both sides, 19.62 equals BB squared. So 10.4 times 19.62 equals 197.1 second squared equals BB. Take the root of both sides. Velocity of B is going to equal 197.1, that's square root 14.04 meters per second. So that's going to be the outlet velocity. So that's how fast it's coming out. The velocity here is 0.04. So that's the outlet velocity here. Okay, so the next question becomes, what's the flow rate? So we're just going to grab it to the board. So remember, Q is equal to velocity times area. So which is equal to the velocity times pi over 4 squared. So I want to find out, what do I want to find out? I want to find out this, I just took numbers on. So this is going to be 14.04 meters per second times pi divided by 4, and the diameter of the nozzle was 4 millimeters, so 0.004 meters squared. Again, calculated time, that's what they invented them for, times pi divided by 4 times 0.004 squared equals 0.004 squared equals 1.76 times 10 to the 4 cubic meters per second. So what's that, about 0.2 of a litre, 0.176 of a litre per second. So a litre of water in there would give us 6 seconds of shooting. Woohoo!